Hello YouTube, welcome back to my channel. So in today's tutorial, we'll continue with our machine learning introduction to machine learning series. In this tutorial, we're going to look at decision tree algorithm. So let's first start by defining what getting an idea of what decision tree is. So decision tree algorithm is just part of the supervised machine learning algorithms that basically has uses a tree-like structure in order to make a decision, right? It's like a tree-like structured classifier. So that's what basically a decision tree is. So in normal life, we usually also can use decision trees in mathematics and in other fields to make decisions, right? So it's the same thing here in machine learning. We use decision trees to make decisions. So for example, let's see how it works using an example where you want to classify a lion and a giraffe. Like you want to classify an animal being either a lion or a giraffe. So one of the things you might consider is the height of the animal, the color, and then the weight of the animal, right? And other factors. So you look at these factors, and basing on these factors, you can decide whether you can come with a decision tree and be able to decide whether the animal is a lion or not a giraffe. Okay, so this is just a simple decision tree that I have. So the first thing we'll look at the color of the animal, right? We consider a giraffe to be a bit yellowish color, while the lion to be a bit brownish, right? So first look at the color. So for example, let's take in the case where we have an animal that is yellowish, so we'll take at the color, look at the color. Is yellowish, is yes, so we move to this side. So we check its height, right? Giraffes are very tall, right? So I googled this and I got the minimum height of a giraffe from being 4.6 and above. So we'll check the height. If it's 4.6 and above, if it's true, then yes, it's a giraffe, else it's not a giraffe. Okay, what if the animal is a bit brownish? We'll look brownish, no, it's not yellowish, no. We'll look at the weight, right? Maybe lions have a certain average weight. If the animal has around that weight, we can say probably it's a lion. If not, it will say it's not a lion. So that's basically how a decision tree is, right? So the main parts of a decision tree, the first part, there are two main parts. There is a decision nodes and then there is a leaf node. So decision nodes are these ones here that we use to make decisions, these ones here, and then the leaf nodes are the ones that have no other branches. So all the ones that have branches are known as decision nodes, and then the ones that have branches that do not have branches are known as the decision nodes. So decision nodes can have two types. There is the parent node and then there is a child node. So the parent node is the one that topmost, and then the child nodes are the ones that follow it, and then the leaf node is the last one that has no other further branch. Okay, so that's what we have discussed. Also the parent, the very top of their these are known as parent node. So this will be the parent node for these two, this will be the parent node for these two, and the very top most, which is the parent of all the other nodes, is known as the root node. Okay, so that's known as the root node. We also have the decision nodes, can also be called edges or branches, and decision nodes decision decisions, right? So just like that. So what is the algorithm behind the decision tree? So the algorithm behind the decision tree is known as the CART algorithm. So the CART algorithm stands for classification and regression tree. So this shows that decision tree can be used for both classification and regression problems in machine learning. So let's look at how attributes are selected. So to select attributes for a decision tree, right? So let me just go back and show you here example. Let's have this thing, right? We have this decision tree. So why did I decide to put color at the first to be the root node? Why didn't I use height as the root node? So this is what we determined by using the what we call the attribute selection measurement, AMS. So the attribute selection measurements can be you can also use we can use entropy, which is a degree of randomness, and information gain, or you can use Gini index and information gain. Okay, these are just the mathematical bit parts of a decision tree. I leave these links below in the description, or you can find it in the notebook. If I forget to leave it in the description, click on the link for my Jupyter page, and then you can find this notebook, and you can click on these links and you can read more about entropy and Gini impurity and stuff like that. So I'm not going to go deep into the mathematics. I'm just going to go straight into the coding section. If you're a person that likes mathematics, you can go into the intricate details of how we choose to put in here color, or to start with the height and stuff like that. So we use this based on information gain and entropy, right? So information gain help us to decide if we split our on which attribute we split on, that will give us the most, like less randomness or something like that. Yeah, so that's what it's all about. So you can go and read about the mathematical bit of a decision tree. That's what we won't go into that in this tutorial. So let's just jump into the practical section. So yeah guys, as you can see, I went ahead and I uploaded our data set that you're going to be using. So I simply imported pandas as PD, and then I loaded my iris data set. Okay, so this data set will be found on this Jupyter notebook on my GitHub link. Okay, so you just click in the description below. There is a GitHub link. You can find the iris data set from there, or you can simply get it from Kaggle. Okay, so I have simply loaded it in. I have just specified pd.read CSV. If you don't know how to read pandas files, I have a whole series on pandas on my YouTube channel, so you can click the card up here and check that video up. So I simply uploaded loaded the data frame, sorry, the data set, and I've printed it out here. So you have that data set. So let me just run the cell, all the cell, everything once more time. You can see we have everything working fine. So let's go ahead and actually begin to prepare our data. So the first thing we're going to do in pre-processing of our data is like to check for any missing value. So I can go iris.isNA okay, then I can check the sum, and then I can run that. So you have no missing values. Okay, so this data set is pretty clean. I already checked it out, so we don't have to worry about feature engineering and data cleaning. We'll look that as we go along. So for this introduction course, we'll be working with clean data set such as this one. So now our data set is clean. So let's go ahead and actually label and code this. So machine learning models do not understand textual data like this, so we need to label and code this. So what label encoding means is that we replace this with numerical values. Okay, so let me just get the unique values from the species column. So I'm going to do iris dot unique, sorry, this is species, the species, I'm going to species column dot unique, just like that, dot unique, and then I can run this. So this method, I can run it. This returns to us all the unique values within the species column. So the iris data set is just a class of it's just a very famous data set in machine learning that consists of flowers, right? So the iris flowers. So you can just Google that up and check out the iris flowers. So the iris flowers of three classes, right? There is a setosa, there's a virginica, and then there is the vesicola, right? Iris vesicola. So we can classify these flowers based on their sepal length, their sepal width, their petal length, and then their petal width, right? So we have all this data. When you have all this data, you can be able to classify an iris flower into any of these three specific classes. Okay, so we get the unique values from here. So in here there are only three classes, and you're going to encode that. So what our aim is going to do is to use a decision tree to classify an iris flower given its sepal length, its sepal width, its petal length, and its petal width, okay, in centimeters. So let's go ahead and actually replace these values with numeric columns, numeric values. Okay, so it's going to do iris, okay, you can get the spelling right, iris. I'm going to get the species column. So the species, check that casing, so it's capital species. Okay, and then I'm going to get the species again, and then I'm simply going to do replace. Okay, if you don't know pandas, again check out my series on pandas on my YouTube channel. So I'm going to replace the iris setosa with a 1, sorry, with a 0 rather. So just copy this value from here, and then I'm simply going to paste it down here. So I'll copy this and I'll paste it here. Okay, I'll paste it there, and then make sure I do not bring those this is iris, it's capital I, and then make sure that I remove that. So, and then in here the value will be 0. So there is a key, and then the value is 1. Okay, so let's also replace this one. This one is iris vesicola. So I'm just simply going to copy this, and then I'm going to paste it here. So I'm going to paste it here, and then I'm going to give it just a value of 1, and then I'll do this for the other one. So this will be iris virginica. So I'll copy this, and then I'll paste it here. So paste it there, and then I'm simply going to replace this with a 2, and then I can run this. So I can go iris, and then we can see now our values have been replaced with these values. Okay, so sorry, something just fell off the table. So we have these values here. We have label encoded the species column. Okay, so now that we have there, let's go ahead and actually remove the columns that we don't need. Okay, so let's go ahead and actually iris the drop, and then I'm going to drop the id column, which is id, and then I'm going to say in place equals to true, in place equals to true. So we have run that. I got the error. Okay, I have to specify the axis. So this is on the, which axis? This is on the row. So axis equals to 1, and then I can run that cell. So we have dropped the id column. So I go iris, and then I can run this. You can see we have the id column is dropped. So now we have this data set. Let's go ahead and actually select our x-axis and our y-axis. So for our x, we're going to have everything except the species column. So I'm just going to do iris dot drop. We're going to drop the species column. So I'm going to go which is species. So species, and then axis, you have to specify the axis. It's on the row, so 1, and then we have there. So let's also now get for the y column. So the y column will just be the predictions, right? So it will be just going to say iris, and then you're going to get the species column. So it's going to say in here species, okay? And then remember that species is a capital letter, okay? So now that you have done that, let's go ahead and actually split our data into the X-train and the training and testing set. So you're going to say from sklearn dot model underscore selection, you're going to import train underscore tests underscore split. Okay, so we are going to import that from Sklearn. We are going to import the train test split library. So this will enable us to split our data into X-train, the testing set, and then the training set. So we're going to go X underscore train, which will be the X train, and then X underscore test, which will be our X test, and then Y underscore train, and then Y underscore test will be equals to the train underscore test underscore split. So this is split, get the spelling right. So we're going to pass in X, our X column, and then our X values, and then the Y, and then you're going to pass in here on which ratios we want to split. So we're going to use 80% for training, right? So training set is 80%, and you can also set the random state here just to be random state. We can give 200, so you can run that. So you can go X underscore train. You can see that we have that value there. So what you have just done in this line is that you have split our data into training and testing sets, where you're going to use 80% for training, and the rest 20% you're going to use it to test and evaluate our model. So I can go, this is the test size, and then the test, and you can see it is 120 rows. So I can go X underscore train, so this will be test, and then you can see X test. So I'm get the spelling right, so we can run that. You can see this is just I think let's just check the shape of it. So that shape, okay, so I can run that. You can see it's only 30 columns, while this one is 30 rows, while this one is 120 rows. So we're going to use this one for testing, and then they're going to use this one for training, while we're going to use this one for testing. So now that we have split our data into training and testing sets, let's go ahead and actually create our model. So we're going to create a decision tree, right? So we're going to start from Sklearn, we're going to import Sklearn. From sklearn.tree, you're going to import decision tree classifier, okay? Classifier, just like this. Classifier, make sure I get that spelling wrong, correct, and then I run that. So now we have imported decision tree classifier. So I'm going to create an instance of it. I'm going to call it I'm going to call it D3. You can call it anything you want. So I'm going to do decision tree classifier, and then in here we're going to just create an instance, okay? So decision tree, and then this will be, make sure I get the spelling right, classifier, okay? It has autocomplete for me. So this will actually be an instance, my bad. So this is an instance of it. So now that you have created an instance of it, let's go ahead and actually train our model, right? So we're going to go d3.fit. Fitting is training our model, so we need to provide in the X train, and then the Y underscore train. So we can train our model. So we can run that, and you can see now our model has been trained. So now that our model is trained, let's go ahead and actually try to visualize how our model, our decision tree looks like, what Sklearn, what the decision tree that Sklearn came up with. So I'm going to go class CN, and then this will just be just come here and copy something. I will show just next second what I'm trying to do. So I'm just going to copy everything here. I'm just going to copy all the classes, right? All the classes in which we are going to classify our iris dataset. So I'm going to copy this, and then I'm going to move down here, and I'm simply going to do a Control V right here. So I have done that. So I'm going to do D3, sorry, what you have just imported here, plot tree. You're going to bring it down here. So plot underscore tree, and then in here we're going to provide our D3, our decision tree, and then you're going to provide class underscore names, which will be equals to CN, and you're going to say also field, and you're going to set this to a boolean true. Okay, so this should be true. Okay, the spelling right, so true, and then I can run this. So this will just plot for us the decision tree that Sklearn is going to use in the classification process. So this is the decision tree that Sklearn came up with in order to classify our iris data set. So this is a decision tree, and it's very similar to the decision tree that we are drawing. So you can see we have a very similar decision tree just like this. So this is how this is the decision tree that Sklearn came up with. So now let's go ahead and actually our model is trained. Let's go ahead and actually try to make some predictions. Okay, so I'm going to bring a X underscore train. This will be X test, and then I'll let me just get the first 5. So I'm going to do dot head. So if you don't know how pandas work, again, you can check out my tutorial on pandas. So the head will just return to the first 5 rows. Okay, so let me just go y underscore test dot head and also get the first 5 rows. So let's try to make our prediction. So let's go d3 and then dot predict. So I'm going to predict a value. So I'm going to provide in here a 2-dimensional array, and this is just going to be x underscore test dot values. Change it to a numpy array, and I get the first one. So you can see I got an error. So let's see, found. Okay, so I think this should be removed, so I should remove one of this. So run this. So you can see that our prediction is 1. So 1 means that it is a 1. You can, if you come up here, you can see 1 mean. What does 1 mean? So 1 means that it is a let me scroll up here. 1 means that it is a iris versicolor, right? Versicolor, iris versicolor, that's 1. Okay, so I can just copy this value here and then this dictionary, and then we can paste it below so that we can refer to it. So copy it and then I'll paste it down here. So move down and then I'll paste it above this and create a cell above that. So just to create a cell above, you just hit this and you press A to create a cell above for you, just like this. So just press A, and if you want to delete it, just press double D and then to delete it. So you can see now our prediction is 1, and 1 is an iris versicolor. So now let's try so, and then if you look here, this was what we passed in. So we passed in a sepal length of 5.5 centimeters, sepal width of 3 centimeters, petal length of 4.5, and then the width of 1.5 centimeters. And then we passed it into the model. Our model predicted that it was an iris versicolor, and if you check the actual data, it was iris versicolor indeed. So yeah, that's how you can make predictions. Okay, you can also come up with your own. Maybe you go to the field and then you collected data on an iris. You found an iris data set, an iris flower, and you managed to collect the data, and you want to be able to print this. So you can just pass in the values. Let's say that we got a sepal width of 5, and then we got this to be 4, and then we got this to be maybe 5 again, and then let's say this was also 4, or let's say it's 2. So let's try to predict, and it predicted to be 2. So this was an iris virginica. So if you get an iris flower having these specifications, then it is probably an iris virginica. So that's how we can make predictions using Sklearn, and that's how we can make our own predictions. So you can collect your own data set, pass it through the model, and then you'll be able to determine which class of iris flower that you have found. Okay, so now that you have done that, let's go ahead and actually build check the performance of our model, like the F1 score, the accuracy of our model and stuff like that. So if you don't know all of this, I have a tutorial on that. You can check it out on my YouTube channel. But for now, I'm going to say from Sklearn I'm going to import from Sklearn metrics. So this is metrics, import classification underscore report. So this will just enable us to print a classification report. So I'll run that. So we can go ahead and actually print, and then we're going to say classification underscore report, and then we're going to pass in here our x y underscore test, which is the truth values, and then the prediction value. So we need to make a predictions of all our data sets. So it's just going to come up here. So be it A to create a cell up here. So we're going to go predictions. Predictions equals to div3 our decision tree dot predict predicts, and then in here I'm simply going to pass in what we want to predict. So we want to predict for all x underscore tests. Okay, so we run that. So we are going to pass in here this return to us the prediction of all the x's. So we can just actually print, we can just go predictions. So you can see we have all the predictions right there. So we're going to pass in here predictions, and then you can run that. You can see we have a classification report. So our model is actually 100% accurate. Wow, it's actually really nice, and you can see all the F1 scores. Our model is just doing really well. Okay, so now to also evaluate this more, to be sure, let's go ahead and actually print a confusion matrix. So we're going to go confusion underscore matrix, just like this, and then we can come down here, and then you're going to create a confusion matrix. I call it CN. So I'm going to go confusion underscore matrix, and then in here I'm going to pass in the y underscore test, and then the y under the prediction. So predictions, and then I'm going to run that. So I'm going to print CN. So we have that predictions right there. So let's go ahead and actually to see if how we can visualize our decision tree. So let me just scroll down here, and then I can do sns.hit. We're going to import first Seaborn, so we're going to import. If you know what Seaborn is, I have a series on Seaborn, crash course on Seaborn on my YouTube channel. So Seaborn is just a visualization library in Python. So we're going to import Seaborn as SNS. So we run that, so sns.hit map, which is going to draw a confusion matrix. We pass in our confusion matrix, and we say this is a not equals to true, so we can be able to see those numbers. So we can see this our confusion matrix, and then all our numbers are on the main diagonal. We don't have any false positive and false negative, so that's why our model is 100% accurate, and the F1 score and other stuff are all accurate. So this is how we can basically create a decision tree in using Seaborn. You can create a simple decision tree. Now this model is actually evaluating to be just 100% accurate, because our data set is not actually very large, and it's not very large. But if you got a very large data set, right, you probably not get 100% accuracy, and then you have to do a lot of tweaking here and there. But looking at this, our model is actually having 100% accuracy because of the small data set that we have. But if you have a very large data set, you probably not get 100% accuracy. So this is actually good, and this is how you can build a decision tree using Sklearn in Python. So I hope this tutorial was helpful for you. Again, if you want to learn how to evaluate the confusion matrix, you can check out my YouTube channel. I have a whole tutorial on confusion matrix, F1 score, recall, precision, and you'll be able to make sense of all these figures, and you'll be able to make sense of the confusion matrix as well. But for now, we can see we have an accuracy of 100%, and everything else is 100%. Okay, so guys, thanks for watching. This is how you can create a decision tree in Python. If you like this tutorial, give it a thumbs up. If you haven't yet subscribed to my channel, please kindly hit the subscribe button. So in the next tutorial, we're probably looking at a random forest. So a random forest is just a decision tree is just a single tree. A random forest is just a multiple decision trees together, right? So you have a multiple decision trees, and then each of the decision trees makes a decision, and at the end of the day you take votes, right? So that's what I will be looking at in the next tutorial called a random forest. So thanks for watching. If you're enjoying these tutorials, give it a thumbs up. Let me know in the comment section below on any feedback on how I can improve this set of series. So thanks for watching. See you in the next tutorial.